Hello everyone. This is our last week 7 material on finding area using trigonometry. We're going to talk a little bit about real world applications. I did leave it a little bit out of the video, but it is kind of why we do trigonometry. So we kind of focus on the applications when can we use it. This will also be on your conjecture, conclusion, reasoning standard for your upcoming assessment. So I'm going to start off by doing a couple of recall slides. What we covered so far back in beginning of the semester, first semester and second semester, we've been really focusing on areas. So on this recall slide, this is where I would probably pause the video, make sure that you know the formulas, write down the formulas, and we're going to kind of use them as references. A couple things I do want to point out is when we look at parallelograms here, we do want to realize that that is still considering all parallelograms. So whether that's a rhombus, that's a square, that's a rectangle, that's a parallelogram, those are all the same formula. It's just part of that. And then when we look at kites and rhombuses, then we're also looking at where D1 and D2 are standing for the diagonals. And diagonals are going from corner to corner. And then the new one, which we decided is going to be the advanced section of this unit or this lesson, will be the regular polygons. This is the formula that we've seen before, and we've kind of just been letting it hang out there, but we haven't really discussed it. So now this is we're going to kind of wrap things up with that. So I like again what I said is I'll write down these formulas, make sure we're familiar with them with today's lesson. And then the next slide is what you've been doing the past couple of weeks, is the recall slide and the trigonometry values. So when you're looking for side lengths, looking for sine, which is equal to the opposite side over the hypotenuse side. So a little refresher here. If that angle is here, this would be considered our opposite. This is considered our adjacent. This is considered our hypotenuse. So I always keep a thing of mine as so ka toa. That's kind of a refresher thing. We want to keep that in mind. So this is another thing that I would write down on top of my page. So knowing the fact that we're going to use trigonometry. So for using side lengths, we're always going to go sine of an angle is equal to a ratio, where I'm going to be giving you the angle. But if you're looking for an angle measure, then your angle is going to be by itself. So you still use this process, but then use what's called the inverse. So those are the things we've covered so far. You've had a couple weeks in practice with that. I'm hoping those are going pretty well, and now it's just a matter of applying them in different cases. So from here on out, I'm going to walk through some examples of what we're looking for and what we're trying to do, and then we'll kind of wrap it up with our video in the end. But again, please feel free to ask any questions that you have. Email the teacher, let us know. We are doing here to help. So looking at example 1, we're given the following figure below. So clearly we can see that since we have two sides that are equal, and which makes two congruent angles, I have an isosceles triangle. So we're kind of wanting to identify the shape, and then from that shape, we are able to should be able to identify that our formula is area equals 1/2 our base times our height. So in this triangle, we're going to kind of look at it as our base, and we're going to put it as to be 34. So I'm going to kind of label this as B. And then our height is always going to be a perpendicular segment that is perpendicular to the base of the triangle. So if I pick 44 as the base, then I want a perpendicular segment going in this direction. But since I'm picking 34 as my base, my perpendicular segment is what I'm going to be looking for. So this right here is going to be my H. So currently in our formula, we have area is equal to 1/2 34 times H that we're looking for. So we don't currently have that. But what we do have, switch colors here, probably shouldn't use green. Let's go to blue. Is if we look at this triangle here, we have created a right triangle that we're given some pieces from. So if we just redraw that triangle, I know that this length is 44, and I know that this length is 65. And I'm looking for the height. So I'm looking for how tall is that triangle based on the fact that this is a perpendicular segment. So now using our trig, since we're looking to find the height, h is considered the opposite value here. So this is considered our opposite. This is considered our hypotenuse. So going back to our SOHCAHTOA, this is the SOH. So I'm going to go sine of 65 is equal to h over 44. Since it's opposite over hypotenuse, we're going to solve for h, put that over 1, and cross multiply. So h is going to equal to 44 sine of 65. So when you type this in your calculator, whichever calculator you're doing, when you type in 44 times the sine of 65, you get h is equal to 39.9. So that right there is going to represent how tall this triangle is. So I'm going to now put that into my formula down here. We'll go 39.9. Multiply those three out. 0.5 times 34 times 39.99. And you get the area is equal to 677.9 units squared. So the biggest idea is making sure we can identify the shape first that will feed into the formula. And then I always try and write out what do I have in the formula, and I label it on the picture. So since I didn't have the height, I wanted to make sure that I broke it into right triangle. You cannot do SOHCAHTOA unless you have a right triangle. So if we don't have this, then we have to do something else in a different process. So that concludes example 1. So let's look at the next example. Example 2. So now I'm giving you find the area of the rectangle. So just a little refresher, we know that rectangles have opposite sides that are equal. And then it has 4 90-degree angles. So we know that this is 90, this is 25, and that makes this one 65. So 65 degrees. So 65, 25, 90. The other thing that we know about the rectangles is that the diagonals are going to be equal. So if I cut from corner to corner and corner to corner, we know those are going to be the same. So looking at the formula, because it's area of a rectangle, we again need to have the base and we need to have the height. So currently, we have the base, we have the height, and right now they're missing for both of them. So I'm going to take what do we have, what could we use to help simplify our process a little bit, is we do know that we have a right triangle with a hypotenuse of 10. I'm looking for the height, and then I'm also looking for the base. And we're given a 25-degree angle. So now this is where our trigonometry kicks in. Again, we're looking for some missing values. So in order to find the area, we need to find those two. So let's just do the first one. Let's look for the height. Height, we have opposite over hypotenuse. So we have sine OH, opposite hypotenuse. So I'm going to go sine of 25 degrees is equal to h over 10. Put it over 1. We're going to cross multiply, and we get h is equal to 10 sine of 25. Punch that in your calculator, and you get h is equal to 4.2 inches. And that's representing this value. So we're going to change that up here. So now I got 4.2 inches as my height. So I've got A is now equal to the base, which we don't have yet, the height, which is 4.2. And now I have some options. You could do Pythagorean theorem to find B. A squared plus B squared is equal to C squared. Or I kind of like to look at my relationships since I'm sticking with trig. I know that this is going to be my adjacent leg, and this is going to be my hypotenuse. So since it's a adjacent over hypotenuse relationship, I'm thinking ca. So cosine of 25 degrees is equal to b over 10. So I still have the same ratio, h over 10 or b over 10. It's just a matter of changing the trig function. So b is equal to 10 cosine of 25. And when you type that into your calculator, you get a base of 9.1. So that gets replaced over here. Base of 9.1, a height of 4.2. I'll plug that into my formula. Then I take area is equal to 9.1 times 4.2, which gives me the area of 38.22 inches squared. So again, we're trying to take what do we have, what are we missing in order to find our area. In this case, we're missing both the base and the height. So we had to use trigonometry twice to get to our value. All right, so looking at example 3, we're finding the area of a obtuse triangle, it looks like. So knowing the formula is area is equal to 1/2 base times height. Let's just fill in what we have right now. We know that our base is going to be 18. And we know the height of the triangle has to be perpendicular to this value. So I'm looking for this value right there. We don't know that value currently. So right now in my setup, I've got 1/2 base of 18, looking for the height. So lastly is I've got my nice right triangle here. So I'm looking for the height, I'm looking for the hypotenuse here. So I have opposite over hypotenuse. So I know I got sine or so, opposite over hypotenuse again. So I'm going to go sine of the angle given, 55, is equal to opposite, which is the h, the unknown part, over the hypotenuse of 12. Put it over 1 and we cross multiply, and we get h is equal to 12 sine of 55. And when you plug in 12 times the sine of 55, you get h is equal to 9.8. So then that's going to represent my height. So I'm going to go 9.8 here. And then I go down to my formula, plug in the 9.8. I take half of 18 times 9.8. And we're going to get area is equal to 88.2 inches squared. Just a couple of things to point out here. We should be feeling pretty good about these area formulas, just a matter of finding out what we need, and now we can just use the values they're given. If you didn't want to use this 55 and you kind of made a different triangle, if this is 55, we also know that then this is 35 up here because of the whole triangles have to add up to 180 degrees. So if you didn't want to use that and you wanted to, let's say you didn't realize it was sine, you could also use cosine and go cosine of 35 is equal to h over 12, and take 12 times the cosine of 35 and get the same value of 9.8. So it's up to you which one you want. The biggest thing is you need to have an angle in order to find a side length, and if you're looking for an angle, we need to have a side length to find it. So that concludes video 1. I'm running out of time here on my limits. So this will be video 1, and then we'll follow up with the next 3 examples on video 2.